Hello, today I'm going to show you how I saved a lot of money by buying a broken monitor and fixing it myself, and I'm also going to teach you how to look for yours and the different faults you can find. This project started when I wanted to add another 24-inch monitor to my computer and saw that the prices for both new and used ones were exorbitantly high. So I said, okay, I'll buy a broken one and fix it myself. But first, we need to understand how a monitor or any television works. Televisions or monitors have first a backlight screen, then the display itself, and when the backlight screen turns on, it illuminates the display, allowing us to see it, allowing the image to be seen. Now there is a source that controls the power of the two parts and a main board or a plate that controls the image. When looking for broken monitors, these would not work for us because the display, which is what is broken here, cannot be repaired. We need one that has a healthy display and for example, it could be this one that says that the power source needs to be repaired, so we could buy a separate power source and simply replace it. But I was interested in one that said it worked but did not display an image, but it did produce sound. This told me that the power source worked, that the display worked, and that the board probably worked since it produced sound, so I bought it. And this is what I found. The monitor turned on fine. As you see, the power source works because the buttons are powered, but nothing is visible at first glance. Yes, that's what we thought, because if the backlight, which was what I suspected was not working, really does not work, we will never see anything, even if the display is in excellent condition. So what you have to do is, with the flashlight of the cell phone, for example, we give it like this sideways against the light and we look for anything similar to this. If we see this, it means that the display is working. And what is not working is what I thought, which is the backlight. It could also be that the main board does not work and only gives sound and does not display an image. But well, those are the risks that one has to take when doing these kinds of things. It can happen. In that case, what would have to be done would be to only replace that board, and that's it. I started by completely disassembling the monitor. Some have more protection, some less, more or less screws, but they are all basically the same. Once you disassemble it, the stick connector is the display connector, and I recommend that you remove it because it can be damaged very easily. It's a flex. And these are the backlight connectors. Since these were for the older liquid crystal display technology and not light emitting diode, there will be 4 cables or some thicker cables compared to light emitting diode. If it's for light emitting diode, it probably has another flex. We disconnect everything and remove this plate that does not allow us to access the internal boards. There are televisions, usually the cheaper ones, that do not come with this plate. And this is the source. The first thing I did is test this same source to see if it gives us voltage at the output that goes to the cathode tubes. If it gives us voltage, it means that the tubes are broken, and if not, the source is broken. As you can see, it doesn't give any voltage. By the way, if you're going to do this, these tubes operate at 700 to 1000 watts. So make sure your multimeter can handle that voltage. Now we already know that what's not working is the part of the board that gives the voltage to the tubes. And the first thing I did was look at the circuits, and I discovered that there was a broken fuse and also a broken integrated circuit. First, I wanted to see if just by soldering making a bridge to the fuse it would work, but it didn't. So what I had to do was get a new integrated circuit and wait about 3 days or so until I could change it. Now, why didn't I do this? Because surely this tutorial would be complicated, as you or anyone who doesn't know much wouldn't be able to change it on your own. So I made a choice that I considered to be the best and the easiest, and perhaps one that you can do at home or anyone who is watching this video. And it's converting the liquid crystal display monitor to light emitting diode. So what you have to do is start disassembling the screen, taking it apart very carefully, and above all, you have to handle the display with extreme care. The display is the screen itself, and it's what we talked about that gives the image. This has several flexes, which are those thick connectors that connect the glass screen, what we can touch, with what goes to the main. These are very delicate, so make sure to remove them with extreme caution. And once we remove them, what we will have left are these polarized compounds that diffuse the light. In fact, I made a video making a lamp with these polarizers. If you want to see it, it's on my channel. I'll leave it here in the corner so you can access what would be the tubes. The tubes that generate the illumination for our TV or monitor, whatever it is that or what we are going to do is remove these tubes that there is no way we can make them work. In fact, there would be a way by putting a transformer of about 1,000 volts or 700 volts or whatever they use. But it's not practical. I prefer to replace it with a light emitting diode strip, which is what we are going to do now. Remove them very carefully because these tubes are made of glass, and if they break, you can cut yourself. So handle them also with care. Manipulate them if you want with gloves or something so you don't cut yourself. Once we remove them, we are going to look for any light emitting diode strip. That is, the closer the light emitting diode are to each other, the better, because they will have a more homogeneous illumination. But I used a light emitting diode strip that I had at home, which is a common light emitting diode strip, which is actually the one I used to make the lamp that I made to film my videos, which is also on my channel in case you want to see it. We will put it in the same place as the tubes placed against one end. Your monitor may have the light emitting diode strips located differently, with the tubes positioned in another way. Simply put them in the same way you found them. That is, if you found the tubes placed in the middle, put the light emitting diode strips in the middle, and so on, always respecting how the tube was originally placed. Now we reassemble everything. We put the polarized ones back on, and I did it while the light emitting diodes were on, but it's not necessary at all. That is, you can do it off. I just wanted to see that while I'm assembling it, I don't break something and then have to disassemble it again. To solder it back on. Well, now we carefully put the display back on, because any minimal damage you do to it will leave you with a line of dead pixels on the monitors, and we all know that's a bummer. So it's better to be careful and not have anything directly left over. We reassemble everything exactly as it was before. And now we have our next problem. The light emitting diode tubes worked with about 700 to 1,000 volts, and that output also didn't work. Now the light emitting diodes work at 12V. So what we're going to do is use a voltage reducer and look on the board for some contact that gives us 15V, 19V, or simply if the board gives 12 volts, we use those 12 volts. If they don't have any of those, look for a small transformer that transforms from 220 volts to 12 volts, and that's it. Now, once we have the 12V on our light emitting diode strip, what we're going to do is make that light emitting diode strip light up when we turn on the monitor and turn off when we turn off the monitor, obviously, because otherwise it's going to be always on. For that, I got one of these relays that they sell for Arduino, which already comes with transistors and resistors. I'm going to leave it in the description in case you want to buy it. And I connected this to the 5V output and ground of the USB of the motherboard. That is, all these monitors have a USB that is activated when we turn on the monitor. So it's the one we're going to use to detect when it's off and when it's on. So it turns on our light emitting diode when we turn on the monitor. And finally, we have to reconnect and put everything back in the same place and the way it was before. The plastic too. The screws, the speakers, everything we took out, we put back in, and comes the most important moment of all. We turn on the monitor. As you can see, it's going to light up all white first because the LEDs light up first and they don't light up at the same time as the display. And when the display lights up, we're going to see that our monitor is already working perfectly. So now we have a monitor that was liquid crystal display before and now is light emitting diode, which means it uses much less light and works spectacularly for very little money. So in conclusion, it would be to look for a monitor or TV that gathers the least amount of faults possible in our graph that we had seen before, as that way it will be easier and cheaper to fix it. So from here I say goodbye, see you in the next video. If you liked it, subscribe and leave a like, as it always supports the channel. See you in the next video. Bye.